25 plus years of pathfinding problems with C++. About me, I'm Raymi. I'm the engineering director at Forgotten Empires and a long-time Age of Empires fan that basically got lost in the code base that is older than I am. I worked on most of the reboots of the legacy titles and a little bit on the Age of Empires 4 as well. Now, I will try not to use these abbreviations. I will try to use the full names because AOE and AOM is hard to understand, but if I do, then, well, this is what I mean. Unfortunately, there's many variations of it because we have so many reboots and so many titles at this point that it's a bit complicated. Now, if I talk about legacy, I talk about the original release of the game back in 1999, or well, around, because all these games have their own release dates. But I will mostly be focusing about Age of Empires 2. And the reboots will be all the remakes and the remasters. All right, problems. There's so many ways things can go wrong in pathfinding, especially in Age of Empires. Starting with the community feedback, that's the stuff that we need to work with. That's the feedback that we get from our users. Unfortunately, it's almost always negative. Yeah, they like to bash on the pathfinding a little bit, but rightfully so. Now, some of this feedback is better than the others. When they compare it to legacy or previous patch, then we get some indication, okay, we have a regression from last patch that must have happened in the last few months. When they give a reproduction case, then, well, that's great, then we know where to look for, or we can try to reproduce it ourselves. But in Age of Empires, we also have a thing called replays. Our simulation is deterministic, so we can use replays to play back a game that happens. And if they provide us a replay and a time at when the pathfinding was bad, then we have a perfect reproduction case. So that's amazing if they do that. Then the next problem. So unfortunately, Age of Empires pathfinding is not taking the easy path. Now, it's really easy path, like what is pathfinding, what is easy, what is hard. Well, in Age of Empires 2, units bump into other units. They stop, they repath, and they basically try to go around it, and they just repeat this until they reach their target or goal. We do not allow for pushing. We also do not allow for overlap, with the exception of formations. Formations allow overlap between friendly units inside that formation. So it makes it a little bit easier, but now we also need to handle formations themselves, which adds more complexity, because now we have two movement systems that need to interact with each other, and yeah, it just gets a bit more complicated. Maps are also fully random and fully dynamic. So every tile on the map can change. At least we are somewhat grid-based, so units do not stick to the grid, but all our obstructions like buildings and water does stick to the grid. Now, if we take StarCraft 2, for example, that is what we strive as like, that's good pathfinding. Players are generally happy with that pathfinding. StarCraft 2 simplified the problem. They went for fixed maps, they went for steering behaviors, which I think is just a better approach to the problem. And they also allowed for small overlaps and units sliding past each other. And that feels a lot better. And it looks also a bit better, even though this example is not exactly the same example. It's a way more complex example. And it's handling it pretty well. So why do we not just do StarCraft 2 pathfinding? Well, we're working on the reboots and remasters. We're not really making new games. It's not that easy to retrofit everything to StarCraft 2 pathfinding. So we would have to rewrite most of the gameplay code if we wanted to do that. We did actually try that in one of the remakes in Age of Mythology Retold. We tried to approach it with a Boyd algorithm. We had mixed results with it. And on top of this, the community does hate on the pathfinding a lot, but they kind of love it as well. And I have an example of this. This is basically a scene where, basically the knights are attacking the villagers, and the other players quickly putting up some houses to block them. And in the last moment, he moves his fishing ship in the path of the knights, and the knights are blocked. This happens in a lot of games, but this specific clip was extra impressive because the player that was actually doing this was using a controller to emulate his mouse, and still managed to pull this off. Now, I would not even be able to pull off the first thing even if I had a keyboard and mouse, but yeah. We would have missed out on a lot of gems in the gameplay if we would have gone with different pathfinding. Next up, Erosion of knowledge. Now, this happens a lot in C++ projects that go over decades, and Age of Empires is one of those. The code base is more than 25 years old at the moment, and yeah, I would say we do not have the worst case scenario. Some of the original developers were around for a while during the development. At the moment, there's none of them, as far as I know. Some of the developers actually wrote articles, and you can still find them online. I linked them on the slides. If you Google for those titles, you can find them. They left comments. They wrote quite a bit of logging, actually. So I think for legacy code standards, this is great, although I've only worked on 5-6 code bases that were legacy code, so I can't judge for all the code bases, but I don't think it's that bad. Now, of course, development happened for more than 20 years. Multiple teams touched the code base, and the pathfinding was always a bit modified. And on top of this, when we got our code drop, we actually lost the source history. We just never got the source history. And I'm saying at least once, because it might have happened before, but I wasn't around in the other teams, so I don't know. So maybe once, maybe twice, I don't know. On top of this, the community also created their own patch for the game, for the original game. They reverse engineered the executable and just changed the assembly and made the pathfinding actually better. Unfortunately, the guy that was responsible for these changes disappeared, and we never got these changes. So the community is taking that patch as the golden standard of pathfinding, and we didn't have it, which meant that when we started, we were basically down 3-0 already. Now, development from our side, we're also not perfect. We tried to fix some of it, the classic. You fix a bug, you get 3 more. It happens. You introduce some regressions, you revert it, and you try to do better. But we also had something that I call ritual programming. When you implement a new feature, you forget to do X, Y, Z because it's just some functions that you need to call because otherwise some system breaks. It's not documented anywhere, the code doesn't error or anything. You just need to remember. All right, now, how does the pathfinding actually work in Age of Empires? So I'm only going to be talking about the short-range pathfinding algorithm, which is about 10% of the whole problem. So you can probably deduce from that how big of an actual problem the whole pathfinding is. So the shortcomings of this pathfinding algorithm is that it's unfortunately undocumented. There's no articles on it. There's no documentation on it. On top, and besides that, it's not performant enough. And it functions most of the time, so sometimes it actually breaks. So how does it actually work? Now, if we want to path with unit A to point B, we start by gathering all the obstructions that are between those 2 points. So we make this square, in this case a green square, and we gather just all the obstructions. Now in Age of Empires, all the obstructions are rectangles that are axis aligned. So that gives us something to work with that is a bit simpler. Next step is we shrink the pathing unit back to a point, and we add what we shrunk back to all the other obstructions. This is just something in geometry to simplify the problem. Now we don't have to path with a rectangle around obstructions, but we just have to path with a point around obstructions, and just makes reasoning about the problem easier. Then we create a convex hull around our obstructions, or multiple in this case. This is done using the gift wrapping algorithm. Now, is our starting point in the same hull as our goal point? In this case, that's not the case. So what do? We try to escape our starting hull. We do this by shooting cardinal rays, so in 4 directions. If we hit an obstruction, we shoot sideways. And we keep bouncing until we actually escape our convex hull. Now, we have escaped our convex hull. We're now going to walk the edges around the convex hull. And at every vertex of this convex hull, so at every point, we are going to try and shoot a ray towards our goal. If we hit an obstruction, we repeat the process. We walk the hull again, we shoot rays towards our goal until we've reached our goal. And the final step is actually just some path smoothing. We just brute force try to remove points and see if our resulting path overlaps with any obstructions. And then the white line is our final path. Now, there is some edge cases that we need to handle. What if our goal is in the same hull as we started or in another hull? There we do something that looks a little bit like bidirectional pathfinding. So we start at our goal and we just repeat the same thing as we started with our start position. We shoot cardinal rays until we escape out of our convex hull. And then we link up the path and you get our path again. Now, what if our convex hull escapes our search area? We expand our search area and we try again. Now, what if we are completely surrounded? So there is not actually a path. Now, this is just the worst case. We do our search area, we expand our search area, and then we do our random bounds of our cardinal rays. And we do this up to 64 iterations, or if there's no more unique vertices to try. Now, when I discovered this, I was like, okay, how did this ship performantly in 1999? Apparently, this was good enough. Like, the code is not written in a unperformant way. It's actually very performant. But what they basically did is they had some early version of hierarchical pathfinding. So for long-range path, they used a different algorithm that was an A-star, a mid-mapped A-star algorithm, which was blazingly fast. And I think that just saved the performance back in the day. Now, this algorithm, unfortunately, has some problem with precision. And it leads to units sometimes walking through walls or houses or any type of obstructions. Now, this turned out to be a classroom example of geometrical precision errors. So when you have the gift wrapping algorithm to create a convex hull, and you have 2 points that are very close to each other, or if they're collinear, so almost on a perfect line, the algorithm does not have enough precision to say, to function. And the way the gift wrapping algorithm basically works, it takes 3 points and it decides, are we making a left turn or are we making a right turn? If we're making a left turn, then we can discard the middle point. If we're going a right turn, then, well, we must keep this point. Age of Empires 2, 3, and Age of Mythology all suffered from this problem. Now, one thing is weird, though, that, well, for some reason they started to occur more recently, and we didn't know why. Now, how does this look in our example, a simple example case? So collinear, these points are almost on the line. It's hard for me even to say if they are making a left turn or a right turn. For computers, they are probably a little bit better at that than I am, but they can also not answer this correctly in every single case. Sometimes the floating point precision is just too low and you get a slightly wrong answer, but for this algorithm, you always must have a correct answer for it to always function. And then the result could be something like this, that our convex hull does not encapsulate all the obstruction, but actually cuts through the obstruction. Now, from what we remember is that if we walk the convex hull to create our path, now this path goes straight through an obstruction, so yeah, this now crosses an obstruction and our unit will phase through anything that obstruction used to be. Now, there's ways you can actually fix this. So Age of Empires 2 developers themselves probably run into this issue because I found this code that actually tries to remove points that are very close to each other. However, this does not fix all the cases. So it was still possible to get the problem. It was just very rare. Then in Age of Empires 3 Definitive Edition, another developer actually also ran into this issue and tried to improve it by upping the floats and promoting the floats into doubles. So now you have 64 bits of a variable that has more precision, basically. This again did not fix the issue, but just made it harder to reproduce, which is still an improvement because now the players suffer less. So yeah. Now, I know another game that also has the community that complains about pathfinding issues. And, well, you sometimes also walk through walls in this game. So it might not just be Age of Empires that is having this problem. And, yeah, I have another case. This was actually my brother that reproduced this one. And it sent it to me. I was like, all right. Now, are we at a dead end? Because, well, the original developers run into an issue, try to fix it. Other developers tried to fix it. Other games might have tried to fix it. And there's just very little information on actually trying to solve problems like this in a 100% guaranteed way. Now, one day, I was trying to just fix this bug, and I disabled the compiler optimization in Age of Mythology, the extended edition. And I didn't do this by switching to debug mode. I did this by actually going to the compiler and turning off all the flags that I thought were optimizations. And that was a crucial difference, because I accidentally also switched off the CMD instructions, which resulted the compiler to fall back to IA32 instructions. Now, why did this fix this? There's a thing called 80-bit floating point precision. It's, they refer to extended precision. Old hardware, when they did floating point calculations, they would use extra wide registers basically to store extra precision in their floating point calculations. This would only work for intermediate results. And then the CMD wrecking ball came. A decision was made to actually drop this extended precision and trade it off for performance. Now, this was probably a good decision, because if you need to remember that you can use your extra precision only in intermediate variables of registers, it's kind of hard to work with, because the moment you store it into a float variable just temporarily, you lose it. Or if you run out of register space, you lose it as well. So it's not very obvious when you have the precision and when you don't. So it's probably for the better that we're moving away from it. But it always leaves me wondering, like, how many applications have run into this problem where one developer one day decided, I want more performance, and did not know that they also were trading in precision. Now, hands up if you actually knew that when you enabled CMD instructions, you would lose your floating point precision. I didn't, so. And apparently other developers as well. So. Now, on top of this, we executed the perfect crime. So the previous company, somewhere around their development time, they enabled the CMD flag, and they didn't notice that this introduced the pathfinding regressions. Now, we came along and we actually disabled the CMD flag, but we also ported the game to 64-bit. Now, 64-bit defaults to CMD enabled. So we covered up that the flag would actually cause the issue. So there was no way, on top of this, we didn't have the source control of the source history anymore. But it was already not possible, but yeah, we also covered it up perfectly. So if I didn't randomly decided to turn it off, we would probably still be looking for the cause of this. So I'm adding this to the list, because we technically also regressed this. But yeah, in the end, the community feedback was probably they were right, basically, because they always claimed that the pathfinding was worse now than in legacy. And even though everyone claimed not to have touched it, we accidentally still touched it in some way. So it finally makes sense why they were complaining. Now, how do we fix this? It actually started as a side project, because I kind of already had given up on trying to fix the precision issue, because I could not find any resources on how to make robust convex hulls. It would either cost a lot of performance, where you would have to write your own infinite precision variables, or you just give up. So I thought, well, okay, maybe we just promote it to doubles and we filter out the close points, and it might be just good enough. But I still wanted to improve the performance issue, because the random bouncing around for 64 times, it's not ideal. There's a lot of n-squared complexity that you run into there. So in big battlefields with like hundreds of units, it scales quite poorly. Now, Age of Mythology actually iterated on the algorithm by replacing the random bouncing with a concave hull pass. So after they've generated the convex hulls, if you had to path out of the convex hull, they would generate a concave hull. And that solves the problem. You don't have to randomly bounce anymore. You can just follow the concave hull. But it unfortunately also suffered from precision errors, because it was again geometry, and it again relied on perfect precision. So now that's algorithm had two phases where it could go wrong, and the community already knew that the pathfinding in Age of Mythology was more likely to get units stuck than in Age of Empires 2. Now, can we do better? Now, what I thought was we're merging rectangles, and there's a lot of ways you can actually do this. I know that there is some union with Boolean operations that you can do. There is some research on it. I could not find something that would work exactly with the expansion of the radius, because every unit can have a different radius size, so then it's a dynamic size that you have to control. So it's either Boolean operations or like pre-calculated, which we cannot use in our case. But the following that I came up with was basically, we pre-calculate whatever we can pre-calculate in a cheap way. So the intersection points of two rectangles or multiple rectangles is something you can pre-calculate quite simple. It's just a simple min-max, a couple min-maxes. And this is also compatible with the radius expansion. You just need to figure out in what direction the intersection point slides if you expand the radius or reduce the radius. Then we pick a starting point on anywhere on the edge, and you start walking it. If you reach the end of an edge, you turn right. If you reach an intersection, you turn left. And you do this until you loop. And there you have it. There's your concave hole. Now, you could turn this concave hole, because this concave hole happens to be a simple polygon. You can convert this back into a convex hole using a linear time complexity algorithm. Turned out that I didn't end up needing it, so I never made that step. So I was thinking, this must be too easy. So can I actually verify if this algorithm works? Because, well, I can just ship it, and then the players would complain when it breaks, but can I do this before I actually ship it to the players? Now, if we have a point on an edge that is not overlapped by any other rectangle, the edge walk will always give us a shape that does not overlap with any other rectangle. Now, this is just a property of this algorithm. And using this, you can deduce some rules that you can check in your code and then output an error whenever this happens. So in the code, I would write something this, like if it's an invalid hull, so a hull that doesn't fully connect, or a hull that infinitely started to loop for some reason, or a hull that overlaps with any obstruction, then I'll just output the path that I was trying to make with all the data that I need to reproduce it. And I can pull it out and put it into a smaller application and start debugging it. And I'm not sure if this actually has a name, but I call it a self-verifiable algorithm. So an algorithm that has something that you can check very easily, and itself can check it. So then basically my path to robustness was, I would run the game with 8 AI players in a team game against each other at maximum speed. This would result in the AI players generating millions of paths for me. So this sounds like fuzzing testing. Then whenever the algorithm would flag it as a failed path or a broken path, basically, or whenever I would see a weird path, or when I would see a unit that got stuck into an obstruction, I would output the path, take it to my application to debug it, and actually fix up the algorithm until the broken path was functional again. And then I would run my test suite that I've generated, because every test case that I've now gathered in the past, I can now check that by running it again and see if it still works. And I did this for a couple of months, and then I got 100 of these test cases. So my test suite was quite considerably big, and with every test, obviously, you get more confident that your changes are actually functional when they all pass the edge cases. Because technically, I would have a suite of 100 edge cases, so 100 bugs that I did not think about when I was implementing the algorithm. And the algorithm would just tell me, like, you're doing it wrong, for 100 times. You do have to go through the exercise of actually going through and fixing all of them. So 100 is it's quite a bit, but it was nice. I would not have known where to even start if I did not have this system. If the players would come back with 100 bucks, for example. Now, a few of these edge cases were simple to solve. So the algorithm that I talked about works in most cases, but if you have perfectly aligning, overlapping rectangles, if you turn left or right on an intersection, you would either walk off your shape or walk into your shape. Luckily, the solution here is very simple. You just go straight. So now we have a third case to handle, but it's not the worst case. And then you would end up with your desired result again. Unfortunately, it was still too easy. I run into more precision errors. So this algorithm relied on plus and minus operations being perfectly accurate. And unfortunately, a floating point path, basically on every mutable operation, you can lose precision. So multiplication and division, you often round, and addition and subtraction, specifically when you cross a floating point range. I'm not sure how that's exactly called, but when you cross a precision range, you often end up rounding as well. And then this, if you have like 180 and you add 1, does not equal 182 minus 1, which to us sounds obvious, of course, but for floating point math, this is not always guaranteed. Now, I did not exactly check if this would actually cause an error, but there is ranges where this would cause an error, and some other person made a table out of these precision ranges where you can see between the range of 1 and 2, a floating point can make a step that is like very small, but when you go to 8 million, the smallest step is 1. And if you cross those ranges, you get different precision in your addition and subtractions. Now, the solution to this was using fixed point math. Precision is only lost during multiplication and division. And this then again allows us to rely on the, 180 plus 1 equals 182 minus 1. So this solved the last problem with the algorithm. And now we finally have a robust way of creating concave holes. Now, in the new way, how do we path from A to B? It's similar, but we don't have convex holes anymore, so how do we do it? First step is still the same. We reduce ourselves to a point and we expand all the other obstructions. Then we actually shoot a ray towards our goal. If we hit anything, we have found a starting edge point. If we hit nothing, well, then we can reach our goal. Now, in this case, we hit something and we find our start point and we start walking our edge. At every point, every vertex, we repeat step 2. We shoot a ray towards our goal. And then, well, there's another obstruction in the way. We repeat the whole process and we reach our goal. Very similar to the original algorithm, just slightly different in how we get there. And yeah, the final step is a brute force smooth again. Too easy again, right? Now, I'm leaving out some of the edge cases because I run out of time otherwise, but a very obvious one is our algorithm needs to loop. It needs to make a full shape. It cannot stop earlier. So if you have a big map and your obstructions hit the edge of the map, that often means you go around the whole map. Now, this algorithm was quite fast, so it could do this in real time for one path every frame. But we do 300 to 400 paths a frame, so that's not going to work. A simple way to solve this is to just add 4 rectangles around our searching area. So in that way, we just basically build in the area that we search by adding some rectangles. And then, you can see what's on the right is what I encircled on the big map on the left. Now, what about our worst case? What if we can't actually reach it? Now, this is obviously a different sample that I took from the game. It looks a bit messy. It's a bit hard to see what's actually going on. The big rectangles are buildings. The small rectangles are units fighting between the buildings. And then you have the forest on the right, which is that messy grid that is to see. And we're trying to path from below to the other side of our battlefield. Now, one neat trick that we can do actually now when we are doing our edge walk is to count how many times we go left and how many times we go right. If we do 4 more rights than lefts, it means we are in the open still. If we do 4 more lefts than rights, that means we are in a hole. And if we're in a hole and our goal is not in that hole, we can never reach it. So this is a very simple early out check that we can now do. Which the old algorithm could not do. And that means, we just need to find the closest point towards our goal, and that's it. We just need to make the path towards that. So now instead of doing several hundreds of objects, merging them into a convex hull, we do one edge walk and one ray, and we know already what our path is. Now, does our new solution have a worst case? I was not actually able to think of a worst case, but the closest thing that I could come up with was basically a very complicated scene where you have lots of objects and there's a very narrow path through this maze of units, basically. So that ends up that you get a very complex shape where you do an edge walk over hundreds of units, potentially, and you shoot many arrays that intersect the same shape that you already have, only to, at the end, figure out that there's just a very narrow path that you can squeeze yourself through towards the end of basically your goal. Now, what does this mean for performance? Well, on average, it runs twice as fast. And this is interesting because I did not actually optimize the algorithm at all. The only thing was the bounds that I added because, well, not doing the whole map sounds like an obvious thing not to do. The old worst case actually was 14 times more performant than the old algorithm. And the new worst case was still 10% faster than what the old algorithm had to do. On top of this, we also achieved quite a bit in the robustness area. So we have the self-verifiable algorithm. So if in the future developers want to work with it, it will slap them when we make a mistake. On top of that, we have the test suite of 100 cases that they can use to check, okay, am I actually regressing or improving the path? And it guarantees a valid answer. It doesn't have a maximum iteration cap after 64 where it just gives up. So if there is a path, it will find it. And that finally led to actually some positive community feedback. A couple of months back, they did a poll. Now, of course, it's not perfect, but it's improving, so that's already a lot. All right, well, it's been a long road. 11 years at Forgotten Empires. We shipped 7 games and more than 20 DLCs. I think the first time we ran into the issue was a bit earlier than that, but yeah, we've been with this for about 12 years, and last year we actually shipped a solution for this problem. So, all right, time for questions.
Hey, very interesting stuff. Did you try with the floats to normalize your coordinates between 0 and 1? Because that's where you have a lot of precision.
Yeah, you have half of your bits of precision between that range. So the problem is that it adds a lot of work when you try to squeeze everything, because you now need to divide it to do the normalization.
Well, you could just work with normalized coordinates from the start.
Yeah, but now your whole game needs to be rewritten to be working with normalized.
But if it's even more points on the perfect scale, then maybe it's worth it.
But the maximum amount of precision that you had is still less than the 80 bits of precision that you had in the old hardware. So that would probably still not work.
Hi, thanks for the talk. I have a question because that's not really apparent to me, is why did they choose floating point in the first place? Because the first thing you learn about floating point is you have 7 numbers of correctness, and anything else, there's no correctness. And with double, you have 23 numbers of correctness. But why did they choose that? Is it so much more performant?
So nowadays on modern hardware, it's actually, I don't think there's much of a performance difference. The reason why I actually chose it for my algorithm in the beginning, until I figured out that I would have issues with it, was because I was also told that fixed point was a thing that I would never be using and never would be needing. So yeah, that's the only reason. I could have gone for doubles, but then I would still probably have run into the issue with subtraction and addition sometimes not working.
Thanks.
How did you, first of all, thank you, amazing talk. How did you keep motivation both for yourself and within the organization for doing what sounds like was a multi-month, multi-year, perhaps, fix of a long-standing bug?
So basically I've been playing these games since I was 4 years old. I absolutely love these games, so I live and breathe them. So that's the motivation behind it, yeah. I just kept on trying to fix it, yeah.
Yeah, I think I may have missed something when you were talking about, so previous company that worked on it enabled SIMD, and then you said you disabled SIMD while you were doing the port to 64-bit. Is
Yeah.
that what you said?
Yeah.
On Windows?
Yeah.
I'm just curious what that looked like, because on Windows, when targeting x64, like it's always SSE2 and above. Like it
Yes.
doesn't actually use the x87 unit and the
Exactly.
80-bit floating point. Oh, okay.
Yeah, so that was the perfect crime.
Oh, I see. I understand now.
I just remembered that I've seen a blog post years ago about using integers instead of floating points for coordinates and stuff in games to eliminate precision errors. Can you comment on that? Wouldn't that have solved at least some of your precision errors?
You mean actual integers?
Actually,
Fixed point is integer based, right?
So yeah, but I mean, placing all your objects on basically tiny grid on a fixed point grid. So then it would be easy to make the decision those points are on a line or it is a left turn or a right turn and stuff like that. Wouldn't that have solved all or most of your problems in the first place? If you don't have arbitrary precision for placing your objects in the world.
So buildings are snapped to tile positions,
basically.
but units can free-form move. But you're suggesting to have units positions as fixed points?
I don't know if units are needed, but your hull algorithms and stuff, those should be easy then.
Yeah, but the whole algorithm includes units.
Oh yeah, I see.
That's why they didn't take the easy way. They actually have really tried to solve a very difficult problem.
Really nice talk. So I'm not 100% sure if I understood everything, but from what I understand, you're using squares, but I wondered if you were to redo this entire project, I know that it's almost impossible to do it with such a large code base, but if you were to start from scratch, would you use like maybe a hex system instead of a square system?
I would definitely keep to squares, but I would go with the StarCraft approach by just simplifying the problem at the very beginning. Players just like that better.
Okay, thank you.
Thanks for the talk. I was wondering if did you ever have like a concerted effort to only improve the code base without implementing new features, or was it always kind of shipping new features and in the process modernizing it a little bit?
There has been some work on trying to modernize the code base. It is never without risk, of course, so sometimes bugs are introduced by doing that. But yeah, we use, for example, we have a task harness that has like over 100 tests. I'm actually not sure, maybe hundreds of tests by now. But we run that to try and catch these regressions, basically. So, but yeah, it's still difficult. So yeah, I'm not sure if there's any further questions, because I can elaborate a bit further on that otherwise. So like we're talking about a C with classes approach of code base. So like move semantics, which you would expect, doesn't work. So if you put something into a vector, you've introduced a bug. It's that.
My company also, we have like a code base from the 1970s with a bunch of C, not even C++, and we're trying to like put C++ in it now, and it seems like very relevant to us. So I was wondering, did you have like maybe like a rewrite process even in mind where you rewrite parts of or the entire code base, or was it just iterative improvements?
Iterative, yeah.
Okay.
So thanks for the talk. I think it was the first video from the Age of Empire where you showed the tech, and I just wondered if it was a pathfinding problem or more a tech target problem, because some of the, I think, writers just walked around the other ones, and I just was a little bit curious.
You're talking about this one?
Yeah, this one, yes. So For example, the red one in the lower is walking around and walking around until he finds someone to attack, and some other are directly up next to him. Sure.
Yeah. So what is happening is here is probably the knight chose a target, but the target was moving. And then the moment he was trying to go it, someone else blocked him, so he had to path around. And in that time, the target moved to the other side, and then, well, you get this weird dance.
So it's a combination
yeah.
of both. Yeah, thank you.
Yeah, there's also in this example, you can see the fishing ship at the end. It doesn't take the best path towards the goal. Like this has different issues, like the high-level pather sometimes kicks in and then finds a non-optimal path, and then the low-level path follows that non-optimal path. It's difficult. There's been many iterations ever since, so hopefully now fishing ships don't do this anymore, but yeah, we're still gathering bugs nowadays. Now, looks like I was quite fast, actually, so I could have added some more slides, but I went over 100 already. I did add, so like usually for a pathfinding talk, you would expect a talk that would mention A star and how that would work. So I had this example that I found. So in the original algorithm, we would gather all the obstructions in this square range. So if you have a forest, that would be a lot of objects that you now need to add to your convexal algorithm. And the new algorithm is more explorative because you shoot a ray and only what you hit you will process. So we've already reduced the complexity of the problem to maybe 5% of the objects that the original algorithm had to handle in this case. Now with A star we can actually reduce this a little bit further. And I had two images. Basically, this is without using A star heuristic, and this would be with A star heuristic. Now, it's not a massive difference, but we go from 5 objects down to 3 objects. So it's, but it shows how nicely. Unfortunately, I don't have the drawing on how much the original algorithm would process. All the way in the...
So yeah, I'm not very familiar with game development at an organizational level, but you know, we make an editor, essentially a DAW, right? And we find that often we have to, like anybody else, we have to triage between feature development and bug fixing. And I get the notion that especially since you're working on remasters, it's the dynamic is a little bit different. You're not expected to implement new features. Do you I guess is the work life, or the flow, are you simply dedicated exclusively to, I guess, making the broken things work, or is there also pressure to deliver features in some way?
Yeah, we actually do new features. We still release DLCs for Age of Empires 2. So there are some new features, and yeah, we try to patch up all the things that we break along the way. Yeah.
Cool, thank you.
Hey, thank you for the great talk. I have a question regarding the algorithm. So how far is the algorithm counting? So for example, if I'm standing in one corner of the map and I see the whole map kind of until the end, will you use algorithm, if I want to go to the other end of the map, will the algorithm count everything?
So this is the short range pathing algorithm. We have a mip-mapped A-star algorithm that basically, it's a little bit like a quad-tree implementation of an A-star algorithm. So it chunks up the map in bigger chunks, so it simplifies the problem a lot. And that one does your long-range queries. And you get certain waypoints from that. And along those waypoints, we use a short-range algorithm to path between those waypoints, basically.
Follow-up question. So when, for example, I don't know the English term, but for example, if you don't have visibility, you don't know what's on the end of the map, how that will work? Or you will like go and see what you see and then change the path, or?
Well, Age of Empires has always supported that type of map hack, so...
Oh, yeah, that's a map hack. Okay, that's why I was pointing at. Okay.
Every player can use it, so it's fine.
Okay. I didn't know, though. Thank you.
So, who of you guys actually have played Age of Empires? Quite a lot. Any other questions about Age of Empires?
It's actually about the pathfinding.
And not allowed anymore.
I guess since like it's not the only thing that you have to do, like just the pathfinding algorithm. So do you maybe have an estimate of how much of your budget of a frame does it take just to run the algorithm, the pathfinding?
Oh, actually, yeah. So when we started the project, the porting project to 64-bit, it was 70%, roughly. So quite a chunk of that time. Now it's more 20%. We optimized quite a bit in the algorithms. So one very interesting fact was that the long-range pathfinding, so the mip-map A* algorithm, its priority queue was implemented using the fastest linked list I've ever run into in my life. It's incredible how fast it was, but it was still a linked list, so it was still really bad for performance.
I mean, just out of curiosity, is your code base, because we had a bunch of talks about that topic as well, is your code base more data-oriented or object-oriented programming?
Object-oriented.
Object-oriented, okay.
It's 100% object-oriented.
Thanks for your talk. I think you triggered my addiction to Age of Empires. Just.
Oh, good news.
So in a year or so, I need to go into rehab again.
And you can complain to me about the pathfinding. Yeah.
So in terms of code structure, repository quality, and so on and so forth, how much history is actually left? Is there a tag where you could actually build the first release, the one that was shipped on CD of Age of Empires 2?
I think we don't have that. Maybe at Microsoft they still have the original release, but at least I have not ever gotten access to it.
So you basically got an archive of source code, which was just then Big Bang integrated into your version control, and that was like the root commit is some point in history that is several years after the initial release. Okay, that's a bit unfortunate, actually. Also for you in terms of understanding the thoughts, but of course commit messages have always been bad and still are bad. A follow-up. How do you version the binary artifacts? So like Git LFS, large file support, was devised especially for game developers to efficiently store the binary artifacts outside of Git, or maybe you aren't even using Git. Can you comment on that?
Yeah, we're using Perforce.
Oh, okay. It's probably a good idea for.
Yeah. Luckily for me, I started with Perforce, so then the bar is a bit low. But I love Git myself, so I would love to move there. But yeah, large binary files are a problem, and we have a lot of them because these sprites, for example, I think our biggest sprite is almost a gigabyte. So yeah.
Thank you.
What's your favorite civilization?
The humans. I like to scout rush and then in the late game spam hussars. Just, I just want to make 2 units, villagers, hussars.
Just a question. So when you get the original tarball of the source code, was it compilable? Could you actually run it, or you have to actually spend all the time, how to even build it?
I think when we got the code drop, I think that one did compile. But for example, for Age of Empires 1, when we did that reboot, we had to actually make it compile. And of course, to port it to 64-bit, some of the code was still in assembly Like it was a mix of assembly and C++. So inline assembly is not supported in 64-bit, so we had to rewrite those areas. And we introduced bugs doing that.
Do you still run into scenarios where you blow your frame budget?
Yes.
And have you considered or tried to then split pathing to multiple frames?
No, we have not considered that. We did that on Age of Empires 1. The downside of that is that your units end up feeling very poorly for responsiveness.
Ideally not for many frames.
Yeah, but yeah, once you go into that death spiral, it's one of those issues that H1 had. Now, Age of Empires 2 always did have a budget, so you could only have like 15 paths a frame per player, and then it would stall the rest to the next frame. So there was always something like that, but we disabled that for human players because we really wanted to have that instant response always.
Any questions I'm not seeing? No. Okay. Then thank you again for the great talk and for the great question and answer session.